Hello, everyone, and welcome to Wastewater Treatment and Resource Recovery, a virtual field trip today. My name is Jacqueline Tarakis, and I am the Expeditions Manager for EarthEcho International. EarthEcho International is a global nonprofit founded on the belief that youth have the power to change our planet. Reaching more than 2 million people in 146 countries, we provide original content, immersive experiences, and trusted resources to empower young people to become leaders and problem solvers in their community and around the world. Today, we are joined by one of our exceptional youth leaders, Akila, and she is going to moderate today's live event. Akila is a senior at Basis Phoenix in Phoenix, Arizona, and she believes one of the most effective ways young people can get involved in their community and begin discussions is through art. To that end, she serves as art director for Arizona Youth Climate Strike, a youth-run climate justice organization, and similarly was on the organizing board for her local youth climate strike. Akila hopes her artivism conveys the necessity of climate justice and furthers action amongst communities. Go ahead and take it away, Akila.
Thank you, Jacqueline. I am so excited to be here, and we are all so excited to have classrooms from all over the globe joining us as we learn about wastewater. This one is especially very dear to my heart because I actually missed out on my senior field trip to a wastewater treatment plant, so I'm really excited for today's discussion. And just a reminder that you can send in questions for our guest host, Shea, via chat on YouTube or the Q&A app in Zoom. And we have set aside time in today's presentation to address those questions. So now let's get started. Please join me in welcoming our special guest and host for today's virtual field trip, Shea Dunifon. Take it away, Shea.
Well, good afternoon, or should I say good morning, depending upon where you are. My name is Shea Dunifon, and I am the Education Coordinator for Pinellas County Utilities South Cross Bayou Advanced Water Reclamation Facility. That's a long name. And as you can see, I take my job very seriously. So today I'm donning a poo emoji hat, and I even have my toilet paper earrings, and I have my special guest here, so I have someone to talk to. So with that, I do take my job very seriously in explaining to the public what we do as an industry, showing people where their water goes when it leaves their homes and what we do before we reuse that water again. So with that, let's jump right into this. Well, not literally jump into this. So this first slide here is an introduction to what is wastewater. So the idea here is not to focus on the water that you see in these images, but where that water actually goes. So many of us take showers, we wash our dishes, we wash our hands, we do laundry, or we flush our toilets. We do this in our homes, in our businesses, our schools, our churches, just about every building we do here in the United States. And the important thing is where all that water goes afterward. So while the name wastewater is a bit of a misnomer because it implies that it could be wasted, right? So all that water that goes down the drains or down the toilets, it has to go somewhere. But this is actually a very valuable resource. And that's why we're here today to discuss this. So as you can see from this simple graphic, hopefully, if you look at the house on the left, you'll notice that underneath the house, there is one single pipe. That pipe is referred to as the lateral pipe. So all the water that you use in your house, whether you use it in your kitchen, your bathroom, your laundry, inside your house or your home, it has to leave through one central pipe. And that pipe connects to what we call the sanitary sewer. So we call it a sanitary sewer. You think sewer, you think sewage, and that's absolutely correct because all the water from inside the building exits through that pipe and it's all collected together in one place. So the sanitary sewer pipes all lead to what is known as a treatment plant, which is what is pictured at the bottom left-hand corner of your screen. So the idea here is that that water is used and that it's filled with things like soap and even sewage. So you have to send it somewhere to get cleaned. We use the term treatment because there's a lot of processes involved. There's a lot of science involved, and we are targeting specific things when we so-called treat that water. Now, if you look next to the sanitary sewer, because I'm here in Florida, by the way, we have what's called storm drains. So if it rains outside, the water that runs off the roof and down your driveway or off the sidewalks or on the roads, it can run off into these catch basins on the side of the road, and then it works through a separate system of pipes where it can end up in a waterway. So for instance, here in Florida, we treat our sanitary sewers and our storm drains separately. They're not a combined system. Versus up in like New England or around the Great Lakes states or even Washington State or Oregon, they have what's called combined sewer systems, where those two systems would be be combined. So in other words, your stormwater and your sanitary sewer are in one pipe. But that's not necessarily true here in Florida. We have separate systems. Again, the key here is that what we're focusing on today is the sanitary sewer. We're not focusing on the stormwater. That still doesn't mean that you should throw pollution out the window. You shouldn't throw things on the sidewalk that could potentially end up in those waterways, because we still don't want to pollute any water regardless of what it is. So I'm going to talk you through a video. This is how you make wastewater. I thought it would be a lot funner to try and make it to show you. This is a demonstration, as opposed to bringing you a real sample, because that would have raw sewage in it. So far I've added yellow dyed water to simulate the number 1. And now I've added some chocolate chips to simulate the number 2. And I'm adding toilet paper. This is probably the most common thing that people do in the morning. And again, this is what our toilets are designed for. So here we're adding some soap, pretend we're washing dishes, hopefully washing our hands a lot more now than we ever have, right? I hope. We're adding some toothpaste. So a lot of these are household products that we use that are designed to travel through our systems. So here's some face wash, that's okay. Now, what is that? Pills. I hope nobody is putting their vitamins or their pills down the toilet. That's a big no-no. Q-tips, tissue paper. What is going on here? Legos? Floss. Okay, this is getting a little scary. Why would people put these things down their drains in their toilets? Cotton balls. Feminine hygiene products. This is a floss pick. We've even got makeup sponges. Oh, and now this is my favorite. The unflushable, flushable wipes. Oh boy, this is gonna get gross, isn't it? So as you can see over here on the right, this is actual footage from our facility of what wastewater looks like when it comes into our facility. You can see there's a lot of garbage in there, right? And I think that's really what we're trying to show here. Cat litter. Oh boy, that's kind of gross. Now, it's a good thing that this isn't real wastewater, because I would definitely have gloves on, I would have glasses on, I would have my whole face covered. I would not be handling this with my hands. So this is just a demonstration, but if you look closely, you might notice that that toilet paper is actually breaking up. That's what those little white flecks you see, they're kind of spinning around. Also, those chocolate chips, well, you know, we know what those are. You can see some other things there. That was the makeup sponge, maybe the Lego. The point being here is that there's a lot of things in wastewater, and some of these things don't necessarily belong in there. See, right here, we have a nice big pile of garbage. This is exactly what we don't want, because if you look on this image on the right, this is something that we see far too common, and it's something that we can't stress enough. Everything that goes down your drains in your toilets is going to end up in our facility. And that just makes our jobs even more complicated when it comes to cleaning this stuff. So again, don't put things down the drains in the toilets that you shouldn't. And here we have a little surprise. I didn't mention that we had some surprises hidden in here. But this is our first one. So this is our toilet trivia. If you can access the Q&A, the chat, you go ahead and take a guess. The point here is I want you to try and guess which country this toilet is from. And the first person to guess, we will give you a shout out in 45 seconds or less. So if you want to take a guess in the chat box what country this toilet might be from, go ahead.
Looks like our first guess, we have Turkey or China, Japan, oh, India.
Yay! Who said India? India
Let's see. India is correct. Yes.
Yes.
And Jennifer Stein said India.
Yay! Congratulations, Jennifer. Yes, this toilet was taken in Bombay, India. So again, let's revisit all those things that are okay to go down the drain as well as the things that aren't. So first and foremost, number 1, number 2, and toilet paper are our toilet's best friends. We'll take that any day. Things like soap. When you wash your hands, you take a shower, whether you use shampoo, that could also be dish soap, that could be detergent. All that soap is okay, that's fine. Also, if you brush your teeth, obviously we're okay with toothpaste. And the last thing is actually water. Now, we don't encourage people to use water without consequence. Don't let the water run while you're brushing your teeth per se. You know, try to conserve water. That's always a good habit to have. But putting water down the drains isn't going to hurt our system because it is mostly water. So what are some of the things that definitely should not go down the drain? Well, first and foremost is my favorite, and that is the unflushable flushable wipes. So remember, from now on, whenever you talk to someone about the so-called flushable wipes, just insert the word unflushable in front of it. Things that are not toilet paper, whether it's facial tissues, napkins, makeup wipes, wet wipes, baby wipes, it doesn't matter what kind of wipe it is, it belongs in the trash, not the toilet. The second item here is grease. That's also a favorite of mine because I love bacon. Definitely tempting to pour grease down the sink, but you do not want to do that because what happens is when that grease cools, it hardens and that can clog your pipes. So that needs to go in the trash as well. You can pour it into an old can, or you could sop it up with some napkins and then put it in the trash, but please don't put it down your kitchen drains. Pills are no-no. Under any circumstance, please do not put any prescriptions down the drains. Please, please, please. And I will definitely come back to that a little later. This next item is a choo-choo train, which is supposed to be a toy. Now, most of the time when toys end up in our system, it's an accident, but we don't want to encourage anybody to purposely put Legos into our system, although I have seen Legos and other weird toys that, let's leave that for another day. Fish. So there is a common misconception, especially in elementary kids here in Florida, that they think that putting their fish down the toilet will send them back to the ocean. That is not true at all. So please, no fish, no sea life, nothing of any sort down the toilet. That is not what you want to do. It's not a good way to go. And last but not least, I've been guilty of this one several times, cat litter. Although it's tempting to flush the cat litter, it definitely does not dissolve in water. So please keep the cat litter out of the wastewater stream. So I did want to take a minute to showcase some of the cool toys that we have in utilities. We have some really cool trucks that I like to brag upon. The one on the left is what we call our TV truck. So you might be wondering, how do we actually take care of our sewers? Like, we don't send people down there to crawl through them. Here in Florida, our sewers really aren't that big to begin with. There's also sewage down there, and there's a lot of gases that can make you sick, possibly even kill you. So you don't want to go down there. So what we do is we actually send a little camera down there. So if you look at the truck on the left, on the ground there, there's almost like a little robot, and you can see it's got little wheels on it. It's attached to a cord. We would actually lift a manhole cover and we would drop that down into the sewer system. And then we have a remote control that looks a lot like a PS4 controller that we can drive that robot through the sewer system. It has a light on the front and it has a camera. So if you look at the one that's directly above, that's a little bit of a bigger one. That one's very exaggerated. The reason I say that is because most of our sewers are not that big. So we tend to use the smaller ones, but it just goes to show you that we have different size cameras for different size pipes. So what you don't think about when you think about sewers is that sewers are different sizes. There's like a whole city underneath us that many of us will never see in our lifetimes, which is really fascinating. But these cameras allow us to do that. So inside that truck, there's actually an office. There's a computer where we can actually watch. So we can see what those cameras see as they drive through the sewers. The idea is that we want to look for cracks and breaks, things that are going to tell us we need to go out there and fix these pipes because nobody wants a leaking sewer pipe, right? The image on the right is what we call a vector truck. I like to joke that this is kind of like a giant vacuum cleaner. So if you look at the back of the truck, you'll actually notice something that kind of looks like a hose. So again, what you can do is you can lift a manhole cover, you can drop that hose down there and you get the idea, right? So it's like a giant vacuum cleaner for sewer systems. And that's really important because sometimes sewer systems do unfortunately get backed up, especially after heavy rainfalls. So we have different kinds of trucks. We have some that are designed just for sewer systems. We also have ones that are designed just for stormwater. And we don't mix those trucks because we don't want to mix those waters, right? So just some really cool toys we got here. Another one, my personal favorite, maybe I just like big trucks, but I like this one in particular because it is the biggest truck we have in our fleet. This is what we call a crane truck. So if you look in the back, you can actually see the crane. And on the right, you can see where it's actually lowered. So we call that the boom. What we use these trucks for is to lift pumps out of a sewer system. So what many people don't know is that sewers aren't just simply a bunch of pipes, they also have pumps in there. So depending how much water you have, also you might be flowing against gravity. Florida is very flat. So imagine trying to keep the water flowing when you're in a very, very flat terrain. So we have a lot of pumps in our systems. So this one on the left is actually one of our larger pumps. You can see it's almost as tall as Mr. Dobby there, who is also my favorite person. I'm gonna say that on YouTube for him. And as you can see at the top of the pump, there's actually a hook. So we call that fishing. What we do is we lower those hooks down into the sewers and we fish out the pumps. And you might also notice that on the ground, there's some white stuff. That could be beach sand because we do have a lot of our pumps in beach areas, but it also could be a residue from a chemical. We do have to treat our pumps with certain kinds of chemicals to prevent rust. So the idea is that we want these pumps to run as long as they can. So just a very interesting thing that people don't think about in our sewers. So where that brings us is to the South Cross Bayou Advanced Water Reclamation Facility. So this is where I work, and this is the focus of the second half of our presentation. So a couple things that I want to point out. First and foremost, this is a really large facility. This is 35 acres in size, so it's very long. The other thing I would like to point out is that if you look on the west side of the property, you'll see that there is a body of water that we refer to as Joe's Creek. That's very important. Most of your treatment facilities are situated next to a body of water because ultimately when we're done treating that water and it's made safe, we can release it into the environment. Now that has a very direct environmental implication, meaning that if we don't do our jobs, we could potentially harm human health and the environment. So we have a lot of regulation that goes on behind the scenes to make sure that we are doing exactly what we say we are, and we are meeting those standards. Otherwise, like I said, we could get in a lot of trouble. So this is a very large facility. We treat as much as 33 million gallons, which is a lot of poopy water, to be honest. That's what it is. And if you look closely, you can actually see some of that poopy water. Those are our aeration tanks over there. Some of our ANOXIC tanks up on the front with the brown water. And then behind that, we've got some of our secondary clarifiers where the water is blue. So it's interesting because the water actually goes from brown to blue to kind of clear. You kind of see that from an aerial standpoint is really interesting to me. So before we jump into the facility tour, there's one thing that I really want to stress, and that was that idea of this misnomer that it's called wastewater. Wastewater simply implies that it's a wasted resource and then that's the end, right? Well, that's not really true. What we do at our facility is what we refer to as resource recovery. In other words, taking all those waste and giving them use. So there's a lot of value in human waste, surprisingly. First and foremost, we take that raw wastewater starting on the left and we treat it so that it's safe and it can be reused again as what we call reclaimed water. Reclaimed water is not drinking water. It's designed for sprinklers, it's designed for decorative fountains, but it is not drinking water. That doesn't mean that the technology does not exist. It does exist, but in order for that to happen, we would then have to take that water and put it all the way through the same treatment processes as we would for raw drinking water. So say like if we were to pull water out of the ground, it would have to go through all those processes again. So we're not quite there yet in Pinellas County, but I will tell you that the science is here and it will probably happen in our lifetimes. The second image is the biosolids. So when I'm talking about biosolids from this point onward, I'm talking about our favorite thing to do in the morning, and that's number 2. So if anybody has a dog and you've ever walked your dog and you didn't pick up after your dog, after a couple days, you'd probably come back and notice that the grass growing where that dog poo was is suddenly beautiful and green. And that's because our waste, our poo specifically, has a lot of nutrients in it. They're not nutrients for us, but they're nutrients for plants. And that's why it's really important. So we then turn that into fertilizer. And that's really important because fertilizer helps us make the money to run this facility. The last thing I want to talk about in resource recovery very quickly over here is energy. So we recover energy in the form of gas. So during the process of turning this into fertilizer, we actually feed that human waste to a lot of bacteria. And when those bacteria respire, they respire gases like methane that are highly flammable. So therefore, they're an energy source. So we can then capture that gas and put it back into our fertilizer factory. And that's very important because that offsets our energy costs by around $140,000. So this is not a cheap operation. So saving money is very, very important here.
Okay, so now we're gonna break for some questions, but I wanted to start with one of my own. This was all super fascinating, but I'm really wondering like how you got into wastewater treatment. I don't know a lot of people who are in it, so I was just wondering like how you got started.
That is an interesting question because I did not choose water. Water chose me. That's what I say. I studied soil chemistry. So there's a lot of overlap in the science between chemistry and how like nutrients cycle in soils. It's very similar to how wastewater treatment is kind of built upon those same sciences. But honestly, how I got into this job, I saw the job opening and I thought that sounds interesting. I have no idea what it's about, but it sounded like a really cool challenge. I like working with the public. I like geeking out and talking about science. And I mean, come on, who gets paid to wear a poo hat to work? I mean, you can't beat that. So
Very valid. Awesome. Okay,
I
so I'm
love
gonna
that.
go to Jacqueline to ask some of the questions we have rolling in.
Thanks, Akila. Yeah, so we have a lot of questions coming in. A lot of them were about how you got inspired to do your job. So following kind of closely to that, what does your day-to-day look like, Shea?
Ooh, it changes a lot, but primarily the mission of our education program, we do a lot of facility tours. So middle schoolers and high schoolers, especially from Pinellas County, will come to our facility. We give them the whole tour. They get to see everything. They get to smell it. It's great. The other thing we do is we go to schools, we do presentations, we participate in events, especially things that are STEM related. So having said that, my schedule is all over the place. I go wherever I'm needed. Sometimes I'm in a school for an entire week. Sometimes I'm giving tours. Sometimes right now in the middle of this pandemic, I'm hanging out at home and doing all kinds of other stuff, writing articles. I mean, it's crazy. It's all over the place, but it's fun.
Great, thank you. Stephanie would like to know, why does Florida have two separate systems when other states don't?
And I might not have exactly the correct answer for that. Here in Florida, I can tell you from just my knowledge of geography, you don't have to dig very deep in Florida before you hit the groundwater table. So that probably has a lot to do with that. But I honestly don't know the historical answer. So I'm guessing it's probably more of a geographical question. But again, we're not very far from the groundwater table. Most of the states that have those combined sewer systems are very deep, like New York, New England. Those sewer systems are like cities underground. If you Google images of like the New York sewer system, it's just like, it's amazing. Same thing with Mexico. I mean, they're deep. They go so deep. Here in Florida, our biggest pipes really aren't bigger than 36 or 48 inches. So even our largest pipes. So it's probably a lot to do with groundwater. We do have stormwater ponds as well. So the idea here in Florida is that when water flows through a stormwater system, it could end up in a wetland. And a lot of times we have these stormwater retention ponds. So it's a more natural process. I guess part of the underlying assumptions here is that you're not going to have raw sewage in it. So when you have human sewage and chemicals, you have to treat it differently than if it's rainwater.
That makes sense. That makes sense. So along with that, are wastewater treatment plants usually county by county? Are there any state or federal treatment plants, or is it by city?
Yeah, so that's a very complicated answer. So here, here in Pinellas County Utilities owns and operates two facilities. I know of at least 12 others within the county, and those are run by different municipalities, different cities. So for instance, like the city of St. Pete has 3 of their own facilities. Clearwater might have a number of its own facilities. So it gets kind of hairy to explain where the lines are drawn. For us, we serve unincorporated areas. as far as, and that's all across the state of Florida. So you go to the next county, you might have county owned, you might have municipality owned, and some are even run by other companies as well. So it's a hard explanation.
It seems very complicated, more complicated than I think any of us ever thought it would be, right?
Yeah.
So Stuart would like to know, back to when you were talking about the different things that we can do with the waste, quote unquote. If you're capturing the gas, why did your picture demonstrate burning it off? What was showing there?
I think we have a little scientist around here because that was a very good observation. The answer is what we do is we capture the gas and we use it as energy. So the fertilizer factory only runs, I believe it's 5-6 days a week. So what happens is on the days when the factory is not running, all the gas that is stored inside that building continues to grow. So actually the short answer is that it's a safety mechanism. So the top of that building, which we call the gas holding cylinder, actually has a floating lid. And when it gets to a certain level, it automatically triggers that structure right there, which we call the candle or the flare. And that burns the gases so that the lid falls back to a safe level. So it's a safety mechanism because those are highly flammable gases. So you have to kind of monitor that. But the idea is that we want to send as much of that gas as possible to our fertilizer factory to use. So we only burn off the excess.
Great. Do you know if California has separate pipes for their wastewater and their sewage?
I don't think so. I want to say that it's more northern than that. The last map that I looked at, I want to say it was like Oregon and Washington state, but that's something that you could easily Google. If you can Google a map of combined sewer systems, or we call them CSOs, you could probably get that direct answer.
Great. And then last question that we're going to take before we go back in. So we had a question about what are the types of treatments that are used on the water, which we're going to get into. So we'll hold that one. And also, everybody loves your hat. I would also like everyone to look at Shea's earrings because they're also really great.
Oh, my toilet paper. Yeah, I gotta get those.
So Natalie wanted to know, before we go back into the presentation, do you ever work with water that might end up in a sinkhole?
Sinkhole. Ooh, gee, I hope not. That doesn't mean if a sinkhole occurred that it could damage a sewer pipe. That would be kind of scary. Ideally, not directly. So the water that we work with directly at South Cross, so it's an indirect answer, not directly. We specifically work with wastewater. So that is water that is piped from a home or a building to our facility. So in theory, it should always be contained within pipes because again, if it's mixed with raw sewage, you don't want that just freely flowing through the soil, because then it could potentially get down to the groundwater table. Now, that does take time, but that's not an ideal situation. So we work more with like piped water. We work with wastewater.
All right. Okay, so we're going to move on with the presentation, which I think we have some more toilet trivia first.
Ooh, do we? Yay! I get excited over these. I don't know why.
They're so fun.
So again, if you think you can guess which country this is, this might be kind of a hard one. You have to think really far north.
We'll just pause for a second. We'll get some guesses coming in here.
I can tell you square toilets are not comfortable, by the way.
We have a guess of Israel. Not that one. Finland.
Ooh, getting close. Getting very close.
Canada.
No.
Nope, other way. Egypt.
Other way. No.
China.
No.
Germany.
Ooh, close, but still gotta go north.
The UK. We got Iceland. We got a couple Icelands, a couple Norway guesses, Sweden, Greenland. I think we might have to give them this one, Shea.
Oh, Netherlands.
Denmark.
And someone was actually taken in Amsterdam, so that would be the Netherlands.
Good guesses, everybody.
Yeah, it was really good. That was a tricky one. So I do want to point out that this is a European toilet. So a lot of times in Europe, they have two separate buttons. They have a button for your number one and a button for your number two. So that helps them conserve water, which is really cool. But again, square toilets, not comfortable. So that actually brings us inside of our facility. So now we get to actually tour and see everything as we go. So the first stop is what we call our operations center. This is the control room. So I like to refer to this as the brain of the operation. Over in the left-hand corner, you can actually see one of our operators. This is Mr. Drew. Don't tell him I put him on the internet. So Drew over here is actually watching all these monitors. And as you can see, there are many monitors mounted on the wall. So because this is a large facility, and as you're going to see all the various processes that go into running this place, and by the way, we run this 24 hours a day, 7 days a week, 365 days of the year off, because people never stop using water, ever. So even during hurricanes, yeah, we might be here. So my point being that you have to watch a lot of what's going on in this facility. Our operators are watching to make sure things are running smoothly. They could be turning things on, turning things off. They could be adjusting chemical feeds, shutting things off. They're also looking for alarms. They have a lot of responsibility. And it's also a really great career option. A lot of people go into this field straight out of high school. So it's definitely a cool option. But again, a lot of responsibility. So pretty cool. So this is where the raw wastewater, which we call the influent, actually enters our facility. It enters through what we call the influent pump station. So you can't see the pumps because the pumps are underneath the ground. So on each side of this building, there's 2 sets of pumps that are bringing all that influent, that raw wastewater, into our facility. Now, if you look on the right side of your screen, you'll also see a picture of a grinder. This is why you don't send us your toys and your goldfish. Because all that raw wastewater that comes into our facility, we pulverize it. The reason being is that's our first line of defense. When you see how much equipment we have here and how tedious and time consuming it is to manage all that stuff, you want to try and protect that. So hopefully you'll break your grinder before you break one of your pumps or your motors. So again, all this water comes in through the influent pump station. And you might also notice all these, sorry, if you go back, all these funny structures right here in the front. That's actually our odor control station. So in the summertime, wastewater in Florida can be a little, smelly. And we do have neighbors that live on the other side of the fence. So as a courtesy to them, we definitely want to try and control our odors. We use caustic, which is like bleach, to kind of keep those odors down to an acceptable level. We can also put out kind of a cherry mist. I don't know, cherries and wastewater is not my thing, but here we go. So from the influent pump station, all of the wastewater then goes to what we call the headworks. So when we start talking about how we treat wastewater, the first thing that we want to do is we want to remove all the trash. So if you look at that dumpster on the far right, we'll both top and bottom over here, you can see all the garbage that we pull out of the wastewater. Most of that is going to be flushable wipes, tissues, paper products, all that stuff that people put down their drains and their toilets that they shouldn't. We try to capture there in screens. So we use screens as opposed to filters because when you have at least 20 million gallons rushing at you, you can't use filters with teeny tiny holes because that will slow down the flow. So this is actually a very highly engineered process. You have to know how much water is coming at you to determine how small the holes should be in your screen. So these holes are small enough that they don't restrict the flow of water, but they capture the majority of the trash. Are they perfect? No. Could it be better? Yes. If people would just stop putting things down the drains and the toilets that they shouldn't, we might not even have this process. So from there, if we're going smaller and smaller, the next thing we're going to want to remove is what we call the grit. So to think of grit, think of things like wet sand between your fingers, something that when you rub your hands together, it feels kind of abrasive. So a lot of people here in Pinellas County, we are famous for our beaches. So lots of people going to the beach. Well, all that's going to end up in our wastewater. Also seeds and pebbles, all kinds of small objects that, again, that abrasive feel. So the idea of the teacups, if you look at the image on the right, is that we put the water in there and we spin it around really quickly. So now we're bringing physics into the equation. If you spin that water really quickly, anybody ever been on the gravitron? You know what happens on the gravitron? You spin it around real quick and you get sucked into the wall. So we spin that water around really quickly, and anything that's heavy will hopefully go down to the bottom. So if you look at the bottom there, you'll see that it goes out and it goes to what we call the grit snail. That clean water, I shouldn't say clean, but it's cleaner wastewater will then move on to the next stage. So this is what grit looks like. This is always my favorite part when I give actual facility tours and I get to show people what grit really looks like. It's kind of a ooh moment. That's not really the reaction. The other one's a little bit more. But anyway, so if you look at the grit, you'll notice that it's a combination of things like corn and seeds and pebbles and sand. And everybody stops me and goes, corn and seeds. Well, what do you think happens when you eat fruits and vegetables? Your body doesn't actually digest those seeds. It doesn't digest corn. You're not designed for that. So you pass that through your system. And whether you realize it or not, it comes out in your number 2. You don't believe me? The picture's right there. So what we do is we then send all that grit to solid waste and it gets incinerated. The next step is what we call the primary clarifiers. So with the primary clarifiers, it's a settling effect, right? What we're trying to do is we're trying to settle all the water out. So for instance, I have here a bottle, some glitter. I shake it up. And what's going to happen is over time, all that glitter is going to slowly start to settle. So in our primary clarifiers, what we're really going after is we're going after the solids. Yes, these. So inevitably, we want to remove all this from the wastewater stream. So these particles tend to be heavy, and they're going to start to slowly settle down over time. So if I held this bottle up for a while, you'll see it's actually starting to settle. So of course, this is glitter in here, but we're going to pretend that this is what we call sludge, which is this guy. So whee! So the idea here in our primary clarifiers is that we want to try and get some of this to settle out, because this is what's going to become our fertilizer. So from there, we send all of our wastewater into what we call the anoxic tanks. And the definition of anoxic means that we're not adding any oxygen to the system. So if you look on the screen, you look in the picture over here on your right, you might notice that it's kind of cloudy looking. When people look into these tanks, some of the observations they say is, wow, those kind of look like blankets, or maybe they're clouds. And what do you suppose that all that beautiful brownness might really be? Well, most people think right off the bat, it's brown, that means it's poop. Well, that's not necessarily true. What you're actually looking at is bacteria, these big, thick blankets of bacteria. These bacteria are hungry. And while most of us think of bacteria, we think bacteria are bad, they make us sick, they can kill us. There's actually a lot of really good bacteria in the world. This is a perfect example of them. So inside your number 2s, there's a lot of carbon. And that is a food source for them. So these hungry bacteria are just eating away at all the solids, breaking them into smaller and smaller pieces. Now, the reason why that process is really important is that they're also helping us to release what we call nutrients from the water. There's a lot of nitrogen in the wastewater, and nitrogen is not necessarily good for the environment. Some forms are good for plants, others can kill. So for instance, the nitrogen that's in your urine, which is ammonia, is actually not good for plants. It can kill them. So these bacteria are targeting those different nitrogen forms. And when you learn the nitrogen cycle, these processes are actually the nitrogen cycle. They're just the little teeny version of it. So again, it's all science at this point. So from the anoxic tanks, the wastewater then goes into the aeration. So because the bacteria in the anoxic tanks used all the oxygen that was available, in these tanks, we actually supply oxygen back to them. So on the bottom of these tanks, there's what we call diffusers or bubblers. So we're pushing air back through the system from the bottom. So when you see these tanks, they're just like these giant bubbling, I call them the champagne of wastewater. They're just bubbling, right? And they're full of bacteria. And these hungry bacteria, again, they're going after the carbon that's in the wastewater, but they're also doing a series of chemical reactions. They're finding nitrogen in the water that has oxygens attached to it, right? I'm sorry. They're actually going after the ammonia compounds in these tanks. So each tank goes after a different nitrogen. So there's a lot of chemistry that goes on in these 2 tanks, like a lot of chemistry. If you like chemistry, email me, we'll go to town. So in these 2 tanks here in our aeration, we've got these bacteria that are going after our ammonia-based compounds, and they're actually converting them into another form, which has an oxygen attached to it called nitrates, which we can then send back to our anoxic tanks. So it's a looping system here. We're feeding our bacteria while we're looping the wastewater back and forth, which is a really clever system because that also means that we're reusing our microbes. We're not just simply moving them from one process to another and then killing them. We're actually reusing them. So it's pretty clever, actually. So after we've removed the majority of the nitrogen from the wastewater, and we might have also removed some phosphorus in those past steps, we then send the wastewater to what are called the secondary clarifiers. So these are probably the most iconic structures that people think of when they think of water treatment. They think of the giant swimming pools. That's why I hear people call them. You might even notice there's a couple birds in there. We don't put the birds in there. One thing that we always have to say is that no matter how industrial your facility is, nature will always find a way. So the birds know that there's no alligators in there. They also know that the water's warm. There tends to be things floating on the surface, especially you see the trees around. So any bugs or seeds that might have blown off the trees, it's free food for them. Now, would I necessarily eat out of there? Probably not, but we get along fine. So if you look closely, you look at the picture on the right, you can actually see what looks kind of like a blade. So on the top of these tanks, we actually have an arm that is slowly skimming the surface. So the idea behind this tank is all based upon density. If something is heavier or it's denser than water, it will sink to the bottom. So you can scrape it off the bottom. But if something is lighter, you can also skim it off the top. So you can see that arm that's slowly skimming the surface or the top. You just can't see the arm that's actually scraping the bottom. And the reason why the one scraping the bottom is really important is because after we left the last set of tanks, we added some chemicals to this water before we put it into these secondary clarifiers. We added chemicals that help us remove copper and nickel from the wastewater, metals, things that are toxic. We also add a chemical called alum. And alum, which is called aluminum sulfate, it binds to the phosphates that are found in our solids, these guys, and it makes them sink to the bottom. So either through the primary or the secondary clarifiers, this is where we remove all of the sludge or all the poop from the wastewater. And remember, that's important because we want to make that into fertilizer. So from here, the wastewater then goes through what we call the denitrification filters. This is a lot of chemistry here too. But the important thing about this step here is this is what gives us the advanced in our title. So we are called South Cross Bayou Advanced Water Reclamation Facility because we have additional processes to help us remove nitrogen from the wastewater. Nitrogen is a really bad thing in Florida if it gets into our waterways. It can cause a phenomenon called eutrophication, which is like algal blooms, and that's not what we want. It's too much fertilizer. So what you can't see here is if you look closely, you can notice that the water's kind of cascading over a wall. It then goes down into a filter, which you can't see, which is made of sand and gravel. And inside there, the water is submerged, right? So there's bacteria inside that sand and that gravel that are also helping us to remove additional nitrogen compounds, as well as what we call total suspended solids. So this is something that I like to refer to as kind of like the polishing effect, if you will. It's just an extra step that we take to make our water even cleaner and safer. And I think we've come to another one of our toilet trivias. I will point out in this one that above the toilet there is what looks like some cabbage leaves. So yeah, this is definitely a very, very old toilet.
All right, we'll pause for a minute and have people put guesses in. While we're waiting for those guesses, Shea, we had a question come in, and that is, have you ever worked with ultraviolet disinfectant treatments?
We're getting there.
Oh,
we do use ultraviolet. Yep.
Mm-hmm. All right. So we have guesses of China, United States, Japan.
Old toilet. Ooh, Japan. No, we might want to go back to, let's try Europe.
St. Augustine, Florida.
Ooh,
Ireland.
Ooh. No.
Africa. Oh, the Arctic.
Ooh.
I've been to Australia. I didn't see any toilets like this in Australia. How about, Germany?
Close. Right next door, I think.
Right? I think so too. Okay, we're getting England, Italy, Austria.
starts with a P. Oh.
Poland.
Poland, yes. Very good.
Right. Who said that? That was Stephanie again.
Wow. We traveled together or something? Yeah. No, this is Poland. This was taken from, it's called Malbork Castle. It is believed to be the largest brick structure in the world. It's a huge castle. You got to Google it. It's Malbork. And you can see that there's cabbage leaves there, which was definitely worth a giggle because, you know. So no more of those flushable wipes. You can always use cabbage and lettuce, right? No, I wouldn't encourage that. I'm not sure that our sewer systems would really appreciate that either, but it's a thought, right? So moving on to disinfection. So since somebody asked, this is exactly what UV disinfection looks like. So the first two pictures on the left and the center, that's actually the UV system. So at our facility, we use both technologies. We use chlorine, but we also use ultraviolet light. So over here, the first picture on the left, you can actually see the top of the UV system. So the idea is that you don't want to see the bulbs because you'd be blinded. So the picture in the middle is we actually removed, like we grabbed one of those boxes and pulled it up. So that's what you're looking at. And you can see all the individual UV bulbs. So I love this system. It is very effective, 15 minutes. The idea is that when you push the water through here, that water is going to flow freely in a serpentine pattern around those bulbs. And you're going to use that ultraviolet light to essentially give those bacteria, viruses, protozoans, anything in there that could be a pathogen and cause disease, you're going to give them a really bad sunburn, which they're not going to recover from. So it's a great technology. But to be honest, you look at all those UV bulbs, it's a lot of maintenance. It's a lot of maintenance. So we like UV, but we're not 100% reliant on it. One day, maybe, we'll see. And then on the right-hand side, we have chlorine. So this is kind of like the swimming pool technology, but take it up another notch. We use chlorine gas, which is much more potent than what you would put in your swimming pool. So that's why it has that greenish color. You might also notice that the walls are kind of funny shaped, kind of sticking out. We call those baffles. So the idea here is that you want this water to be in contact with this concentration of chlorine for 15 minutes. That is called the contact or the killing time. That's a very sciencey term to know, by the way. So the idea is that you want that water to be in contact with that chlorine for 15 minutes, and that's going to disinfect it. So again, the ultimate goal here when it comes to recovering resources is one of the products we make is the reclaimed water. So you can see the storage tanks on the left. Underneath it are the purple pipes. So we always say purple pipes, think plants, purple's plants. So we color code all of our different pipes so that we don't mix them up. So if you see purple pipes, that's reclaimed water in Florida. If you see blue pipes, that's potable or drinking. And if you see green pipes, well, those are sewer. So yeah, just don't touch those. And you can see on the map in the middle where those storage tanks are. So again, because we are kind of landlocked where we are in our facility, we have to store our reclaimed water inside these large tanks. Each one of those tanks can hold about 6 million gallons. And ideally, if you look at that picture on the right, you can see where the reclaim lines are. So we want to send as much of that water out into the public to use for sprinklers and decorative fountains, because that helps us conserve our potable water, which is very important in Florida.
Shea, before you go on, we had a question come in about the UV. And is the UV treatment that you do on the water, is it the same idea as using UV sterilization while backpacking, but just like on a bigger scale?
So I'm not really familiar with what that is in backpacking. I don't know what that is,
yeah, I'm not
but it's
sure.
Probably, I mean, the idea of a UV system is, right, it's the light, right? It's the radiation that it gives off. If you go outside and you're not wearing sunscreen, you're going to get sunburned, right? But the idea is that when you have that much UV light concentrated on a cell, it damages the DNA, right? So if you get really bad sunburn, potentially you can get cancer, because what happens is those cells become damaged, the DNA becomes damaged, it can't replicate correctly. Same thing happens to a bacterium, right? If it's a single cell and you destroy the DNA, you mess it up, it's not going to be able to replicate. So it's probably similar, but I don't know what specific that technology is. I'm assuming maybe it's a UV in a glass or something, like in a cup or something. Yeah, that's what I'm thinking
too. Probably for drinking water, maybe. I don't know.
Yeah, if they can reiterate, I could probably answer that.
Okay, thank you.
Sorry, I can't say I know everything. I'm not always an expert, right? So the last thing I want to cover very quickly, because I know you're all wondering, is what about the poop, right? Next slide. Yep. So what we do after we separate all the poop out, right, all the sludge out in the primary and the secondary clarifiers, is we feed it into one of these two digesters. So the screen on the left, exactly, the picture on the left is one of our digesters. So you think digestion, you think stomach. So that's essentially what this is. It's a stomach. There's no windows, there's no doors. All the bacteria in there are anaerobic, meaning they don't like oxygen, right? So you put all that sludge, you put all that poop in there, and then they start to eat because, again, the carbon is their food source. They eat, they die. Next generation of bacteria comes along and eats, they die. This goes on and on for about 2 weeks. So then we take all that sludge, we move it into the middle building where we store it. And that ultimately is what we are going to make into our fertilizer, which is what you see on the far right. So this is what we call organic fertilizer. In other words, it has a really high carbon content. So when you put it on a plant, the plant does not shoot to 20 feet tall the next day. It takes time to break down. You need microbes in the soil to kind of feed away at it. But what's really cool about this fertilizer is that really you can stick your hand in it. It's not poop. It's actually the remnants of the bacteria that ate the poop. So that's why it's pretty cool. It's kind of like castings of bacteria, if you will.
That's very cool. With the fertilizer, Shea, do you use any of the grit for fertilizer since it has materials that could be used as fertilizer, and why not?
Well, the simple answer is because it's been in contact with human sewage. Doesn't mean that it couldn't be composted. That's actually something that we've looked into possibly doing. But again, there's always safety concerns because it's come into contact with human waste. So, you don't want to handle somebody else's waste. You don't know where they've been or if they have any illnesses. But it's something that could be composted in theory. And that's why there's such thing as composting toilets, right? Kind of built upon the same idea. I can tell you that when we remove all the grit from the wastewater, there's tomato plants everywhere. Like there's plants everywhere because all that stuff grows. So we always know where our grit removal is because you drive by and you see these giant tomato plants with these big, beautiful tomatoes. And we try to leave them there just to show people. But then eventually we do have to take them down because you don't want that temptation, right? So the last resource that we recover at this facility is actually gas. So again, kind of going back to that idea that as these bacteria are eating away at these solids, they're producing gas. And we collect that gas and then we send it back to our fertilizer factory where we use it. And again, that offsets our energy costs by about $140,000 a year, which is significant. And as one of you pointed out earlier, yes, this is a picture of us burning it off because that is both a safety mechanism. It's also kind of lowering that level that's inside that center building called the holding cylinder. So we only burn off excess. We try to use as much as we can. That is the goal here. So I do want to make a shameless plug for careers in the field. Obviously, you have to have a sense of humor. I mean, at least in my position. But we have a lot of positions. We have everything from electronics, mechanics, operators, chemists, microbiologists. We have people who've come to work with us straight out of high school, all the way up to doctorate degrees. There's a lot that goes on in the background that I can't even cover in 45 minutes. You have to think about all the people that maintain the sewer systems. You have to think about all the administrators, the people who deal with the customers. There is a lot that goes on in the background. So there is no shortage of jobs right now, and we are all very essential. So even though I myself am not physically at the facility, people like Drew and Lee and they're all there right now working. Our operators are there. They don't get to stay home. So definitely think about those people. And of course, we had to throw one more toilet trivia in before we finished. So this one is also in Europe. That's my clue.
Right. So as guesses are coming in for that, we had a question come in through YouTube. And do you know if in smaller towns, do they shut off the main water at night and use water in towers? I don't know.
I do not know that because I do not work in drinking water.
Yeah, that's true.
Sorry.
So that's okay. That's one we have to Google, and that happens. All right. We have a guess of England for this toilet.
Ooh, not quite. More mainland.
Ireland.
Mainland.
Denmark. Rome. Scotland. These are great guesses.
B.
Starts. Oh, we have Belgium.
Belgium, yes.
Let's
This
see
is
who
in
that
Belgium.
came in from.
And I have to look at the answer because
It was Jennifer.
there's too many castles in Europe. Jennifer, congratulations. So this is in Belgium. This is probably one of my favorite bathrooms because if you see the arrow, like literally, that's all the privacy you get, which I thought was really funny. So a lot of these bathrooms like this one, you literally go and it falls down a hole into a moat. So they always had moats around some of the old castles, and that was kind of a deterrent. Like you didn't want to storm the castle knowing that you had to go through, that. So it's a nice natural line of defense. But this was at the Castle of the Counts, if I remember correctly, or Gravenstein, which is in Ghent, Belgium. Great chocolate.
I didn't know that's what moats were.
I read it one time and I was like, that makes sense.
I know that you were kind enough to share some of your information. You want to talk about where people can follow you real quick?
Yeah, so we have a full-time education program here in Pinellas County Utilities. So the first one is our website. So we have a lot of resources. They are mostly for middle school and high school because we do stress the STEM a lot. Like we really get into chemistry with some of our groups. But definitely go there and check it out because we make a lot of announcements. We have curricula there for middle and high school teachers if you're interested. The second line is our email. So of course, if you want to email me a question, that's fine. I could probably give you a better answer. But don't ask me about drinking water. That is not my expertise. I'm only in this. And then the last one is a shameless plug for our Facebook. We do the Florida Water Festival. It's a biannual event that we do in the Tampa Bay area. Everything to do with water and just a really cool event, I guess. It's my shameless plug.
Okay, so we're going to take another quick break to answer any last questions. Jacqueline, do we have any more rolling in?
We do. So Jenna on YouTube would like to know, Shea, have you visited all of the toilets in the toilet trivia yourself?
Yes.
All right.
Those are my pictures, except the first one was my friend. She's from Bombay. So I didn't take a picture of a toilet in India. So when she went back to visit her family, I was like, hey, take me a picture. But yes, I have been to India, and I will tell you a funny story. I went to India in 2007, and when I landed in Chennai. I really, really had to go to the bathroom. It was a really long flight. And when I first saw the toilet, I just had a cultural shock. Like I didn't know what to do. I really didn't. And it made me really appreciate, the toilets here because they're just so convenient. But still, it's really important. There are a lot of countries out there that don't have access to sewer systems, that don't have access to toilets. So it really makes you appreciate where you are and where you go. So I learned a lot about culture in India, and it is like one of my favorite cultures. Their food is phenomenal. So it was just a great trip. But yes, I had a cultural shock at that. And when I had to go plug in my phone and realize that the jacks were completely different, I was in a lot of trouble. But it was still the greatest trip of my life, hands down, hands down.
Great. So Jaden wants to know, do you use polymers to help separate the clean and dirty?
We do add polymer to the water, yes. We also add polymer later on when we're working with the sludges. We have to thicken it up. So I didn't even get into how we make the fertilizer because that is like a whole separate discussion. But yes, our polymer bills, yes, we definitely use polymers.
Maybe we can have you back for another virtual event.
We're doing biosolids now, right?
I love it. Akila, did you have any last questions?
No, I don't think so. This is very informative. Thank you so much.
Yeah, so I'll let you go ahead and wrap it up, okay, Akila?
Okay. So yeah, thank you everyone for the great questions and obviously the great answers from our wonderful host, Shea. And we would also like to say a special thank you to the Northrop Grumman Foundation for their support. And stay tuned to earthecho.org to find out more information about all of our exciting programs, including upcoming virtual events just like this one. And be sure to stay connected with EarthEcho on all our social media channels. A lot of exciting things coming up. And on behalf of EarthEcho International, thank you for joining us. Stay safe and keep exploring.
Wave him.